Hey everyone, so this is another question based on lesson 5 where we talked about how we can take values to solve the question. So let us very quickly solve this question and see whether we can take any values and get the correct answer. So in this question it is given that p is a prime number and we need to find out which of the following statements must be definitely true. Okay. Now, whenever you're given a prime number and you're asked which it must be a true question, then that means it must be true in all the possible scenarios. So, when we talk about prime numbers and we think of all the possible scenarios, this is how ideally you should break down and think. So we have an even prime number, okay? Then we have 3, okay, which is an odd prime number. I'm writing 3 separately because these are the only two numbers which cannot be written in a specific form, and the other prime numbers which can be written really like this: 6k plus 1, 6k minus 1, and these are prime numbers which are greater than 3, like 5, 7, 11, and so on and so forth. So when I'm looking for the answer, I need to ensure that I check all the possible cases. Now some of you might just check one of them, mark the answer. If you do so, you'll end up making a mistake. Okay. So let's look at the first statement. Keeping this in mind that we need to do this, let's look at the first statement and see if this is always true. So I have p plus 3 times p plus 5 times p plus 9, and I need to find out whether this is definitely divisible by p or not, divisible by 8 or not. So obviously what you can do is you can take the first scenario, you can take p is equal to 2. If you put 2 here, you'll get 5, 7 and 11. So you can notice that if you put 2 here, you are getting 5, 7, 11, which are all odd, and obviously if you divide it by 8, you'll get a remainder. So this is not divisible. Okay, so you can so in this case you don't need to check any further, because just taking p is equal to 2 clearly tells us that this is not possible. Had this been completely divisible, I would have gone and checked other cases also. Okay, now let's look at the second scenario. The 6p plus 1 times 6p minus 1 must be divisible by 6. Now p is a prime number once again, so I can start with 2. But notice if I take 2, both these numbers will be odd, right? 12, 13 and 11, and even this is not divisible by 6. So here we're kind of lucky. In both the cases nothing worked out, so obviously even this is not true. Now if you want, you can check the third one, but since none of the options, none of 1 or 2 are true, so this cannot be answered, this cannot be answered, this cannot be answered. So the only answer possible is option B. And if you want, you can check it very quickly. You have p square minus p times p plus 1, and you can write this as p. If you take p common, you'll get p minus 1, p plus 1. Okay, now you can put 2 to check it, but this is here it is really not necessary to take values. If you're able to notice carefully, this is 3 consecutive numbers. P minus 1, p and p plus 1 are 3 consecutive numbers, and this is always irrespective of the value of p is divisible by 6. Always. So if it is divisible by 6, it will definitely be divisible by 3, and hence the correct answer in this case is option B. But keep in mind, guys, that even if you're taking values to solve the question, you were lucky here, you were able to eliminate it very quickly. But just in case, if any of them would have become divisible, then you would have to check these two cases. So this is another important thing that I wanted to tell through this question, and I hope this is perfectly clear.